So basically, in order to achieve the confidentiality, integrity, and availability, the security objective, we rely on security controls. And security controls is the safeguards that we are using in order to protect our assets from various security threats and security risk. Security controls help in minimizing the security risk to assets, and security controls is not only something technical, it could be also non-technical. For example, when I establish like a security awareness program, it is a kind of control because security awareness program can reduce the probability of having a phishing email opened inside my organization. In that case, security awareness program is a control, but it is not a technical control. In case of the code of conduct, HR policy, privacy policy, security policy, all of it are kind of policies and documents that the organization is maintaining. It is also a control. And in that case, it is a deterrent control, administrative deterrent control, because it is administrative, it helps in establishing the governance, and at the same time, it reduces the likelihood and gives the users and employees what is the information about good practices that they need to have and adopt. By the way, when you select a security control, you need to make sure that the cost of control does not exceed the cost of the asset that you are trying to protect. When you do a security investment also, when you invest in acquiring a security control, return on investment is not only the thing that you are going to consider, but you can also consider the return on security investment in order to realize what is the benefit of having this security control. What I'm trying to mention here is if you decided to acquire, let's say, a new software for IT operation, to help you in, let's say, creating more scalable systems and high availability and redundancy. This system might not be able or might not be directly traceable to increase in revenue, but it could lead to more availability, more customer satisfaction, more adaptation or more compliance with SLA measures and so on. So here you are not having a direct increase in revenue because the software, but you have indirect factors or indirect results that will help in increasing the overall revenue. And that's what do we mean by the return on security investment. So return on security investment cannot be translated directly in terms of enhancement or increase in revenue, but it enhances other factors that can in turn enhance the revenue, such as the customer loyalty and all of that stuff. Controls in general can be categorized as, like as I mentioned, technical or non-technical, can be correct, can be administrative, or can be technical and can be physical controls, as well as it can be categorized according to its function. Like, for example, we could have controls that are preventive, like security gate. It is a preventive control. Security camera. It is a detective control because it can detect the incident. Deterrent control, like warning banner, like when you access to a database or a restricted system, you have like a warning banner that telling you that this system is restricted and authorized only for authorized individuals. So in that case, it is a deterrent control because it reduces the likelihood of someone that gaining access to the system in an unauthorized way. Controls also can be corrective. For example, backup and recovery. In backup, for example, I can use backup in order to reduce the damage or correct the problem. If something bad happened, I can simply reverse back the operation. That's why we have also controls that are corrective controls. So generally, when we compare between this classification of controls, we can say that preventive controls can prevent the issue, detective control can detect and report the issue, corrective controls can minimize the impact and remedy the problem and correct the error or reverse the error. Deterrent controls can help in reducing the likelihood of violation. When we look to how all of it work together, we can say that when someone, if we talk like a practical example of cyber attack, And what is the relation with security controls with cyber attack? We have an adversary that is using a threat. An adversary refers to someone who is doing the malicious action. He will use or she will use a threat to create an attack, and using this attack, they will be able or they will be able to exploit a flaw or a vulnerability in the asset. As a result of this exploitation, he will be able or she will be able to cause an impact. So by having security controls in place, if we have a deterrent controls can help in reducing the likelihood. If we have detective controls, it can help in detecting the attack while it is being performed. And as a result of this detection, detective controls can trigger the response from of the preventive controls, which can protect the asset or protect the vulnerability or prevent or limit the damage. At the end, we can use the corrective controls in order to reduce the damage or by restoring data. So let's go to a practical case here. If we are talking about physical security and we are talking about fire suppression system, for example, in fire suppression system, deterrent controls could be like the fines, could be like the policies or the process or termination process in case someone smoking in restricted area or something like this. This is deterrent controls. It reduces the likelihood. But for detective control, we might have the smoke detectors or heat detectors. Smoke detectors and heat detectors can detect the, I will not say the attack, but could detect the threat, which is the fire, which can burn the assets in order and will cause an impact. So detective controls can detect the fire and they can trigger the response of the emergency team or even release the gas responsible for suppressing the fire or releasing the water valve that is responsible for draining everything or let's say making everything wet. So detective controls detect the error or detect the incident or problem and also trigger the response. Preventive controls will work in a way to reduce the damage if the damage or if the fire already started, or can kill or terminate the root cause of the fire from the beginning. So when I sense smoke, I will just release the gas and I will kill the fire or terminate the fire in very early stage. So it will protect. And if the fire already started and started to burn some portion of the asset, by using preventive control, I can limit this damage. Corrective controls after then can be in form of like DR. If I have this fire incident in my data center, this will cause my data center to be out of service. So by using my high availability site or my DR site, I can decrease the impact. If I might get like 24 hours from system disruption, using DR, I can reduce this amount of time after considering RTO to like 18 hours. So in that case, it helps in reducing the damage or in this case of corrective control. We can apply this scenario in any kind of incident. In case of virus, we have antivirus solutions that can detect and prevent, and we have a backup solution that can correct and decrease the damage. In case of physical security, we have a fence and we have security guards and we have whatever controls. So security controls have great amount of examples. And as I mentioned, these examples could be technical, non-technical, and physical. For detective controls, we might have our SIM solution, which is about log aggregation. Vulnerability scanners can help in detecting the security vulnerability, so it can help us in prioritizing the patch management process, depend on the criticality of the vulnerability. Intrusion detection is a detective controls because it detects only the issue without preventing it. Intrusion detection can be the intrusion detection system in firewall, or can be like the motion sensor. It could be like an intrusion detection, but from the context of physical security. Administrative detective controls could be audit. So audit is a control. The process of audit is a control because it helps in detecting the non-conformities and help in raising these points to management so we can work on it. Security reviews such as security assessment, mandatory leaves which require some employees, for example, to leave the work or take a mandatory vacation for 2 weeks. This is, by the way, an applicable scenario in case of HR, in especially in financial sector. In banks, there are some regulations or some local regulations that require bank employees to take a mandatory vacation, and during this mandatory vacation, they will have no access to internal systems. This can help in detecting the frauds or if some wrong is going on. Quality control department is our quality control process is a detective control. How? Because quality control aim to check the product specification against the standard. So if the standard is not met, in that case, we will not be able to approve the release of this product to production, for example. So for physical control, I believe the list is long. So we have motion sensors, the laser beam for deterrent controls, system login banner, monitoring tools. I do not need to explain a lot of it. Maybe we will go through the course and we will discuss what do we mean by XDR, what do we mean by IPS, what do we mean by WAF. But again, the security system or the security controls is not only a single aspect that we are trying to protect, but we should use a combination from all of these together. Like when we look for a preventive control, we should have a change management process, quality assurance to establish the standard, segregation of duties and job rotation to make sure that no one will know all aspects about the system and there is no ultimate authority in the system. There should be like a segregation in duties, security awareness. All of that are preventive combined with technical controls, because having administrative controls only does not provide or does not guarantee 100% of compliance. You should have a kind of enforcement, and this enforcement can be achieved by preventive or using technical or physical controls. I hope that's clear for you. So security controls is a very wide topic, but generally security controls, as we mentioned, can be technical and non-technical, and you need to make sure that the cost of control is selected based on how this control should perform and what is the actual uh, asset value that this control is trying to protect. What do I mean here is when you select a security control, you need to consider that whether the control is achieving the objective of it or not. Like I'm purchasing an antivirus solution, so it should help me in countering viruses, for example. So here, what do I mean by a control objective? Also, I should consider that this security control cost should not exceed the total value of asset. Like I having a system and this system is generating a revenue of 100K per year, I should not implement a security control that cost me like 200K. It will not be reasonable to have something like this, because control cost should not exceed the cost of the actual asset. Or let's say the total cost of ownership, to be more specific, should not exceed the cost of the asset, because maybe the cost of the asset may be 100,000 and the cost of control might be 100,000 or 20,000, but I need training and the maintenance and the licenses and efforts that can reach or make the cost of the control equal to the cost of the asset. This is not acceptable. And that's what do we mean by total cost of ownership. This is not only the cost of control, but all associated costs that can help me in maintaining this control in a good standing. So control objective, as we mentioned, is the actual goal of having this control. And as we have a clear definition for the objective, it will be very easy for us to identify the performance indicators that based on it, we can regularly monitor and evaluate the control performance. So how we can perform a control testing? From time to time, we need to do control testing in order to make sure that this control is achieving the control objective. In control testing, we start by identifying the control to be tested. Like we use the inventory and then we decide or figure out what are the controls that we have. We prioritize the testing of this control based on the criticality of these controls. Then we determine what is the testing methodology to be used. Like we might consider penetration testing. We might consider control self-assessment. We might consider using a software static analysis tool. So whatever the methodology is being used and the tool, it need to be defined. We develop test cases and we run these test cases and analyze the results. And based on that, we do follow up in order to make sure that the identified issues, if we identified any issues, that these issues are going to be fixed or will be fixed in a timely manner. So having the control in place is a good, but you need on regular intervals to perform control testing to make sure that this control is achieving the control objective. Because if the control does not achieve the control objective, we will need to fine tune or restructure or recheck how we can enhance this control. So in order to perform control testing, you might have some standards or some guidelines that you can follow. For example, you might have your local standards, and based on these local standards, you can develop test cases or test scenarios. Some security vendors, in case of firewall, databases, database monitoring solutions, same solution, might also have their own hardening guidelines. So hardening refer to the minimum level or the baseline security required configurations that you need to have in on your system. So you might do an assessment against what is configured and what is mentioned in the vendor requirements. For example, in cloud environment, we have the CCM cyber cloud capability metrics. I believe this is a right naming convention or not, but we have like a tool that based on it we can do a self-assessment, and this self-assessment is known as cloud controls metrics. And using the cloud control metrics, I can evaluate what is the existing controls compared to what is the controls mentioned or identified by the Cloud Security Alliance to Cloud Security Alliance to confirm if I possess high level of security in my cloud or not. If I need to certify against an ISO 27002, for example, or ISO 27001, I can use the control list of ISO 27002 to test the controls that I have in place. If I need to conduct any further testing, I can rely on penetration testing service, code review service, vulnerability scanning reports. All of these can be used for control testing. So as we mentioned before, we need to select the control based on the cost of the assets that we are trying to protect, and also based on how this control is achieving the objective. So as long as the control cost is reasonable and the control objective or the objective is met, we will select this control as long as it will provide value for our organization. And this value, of course, will be reducing the level of risk. But in some situations, we might not be able to apply the required control because of some limitations. For example, what is the control for achieving data confidentiality? Encryption, for example. But I have an issue with this kind of application or with some servers, that these servers are running like a legacy application, and this application does not support the encryption. So what should I do in this case? I might segment or segregate this application in a dedicated VLAN or a dedicated subnet and require users, whoever need to access this application, to log in first through an RDP machine, and using this RDP machine, they can reach this network where this application exists and do the job or do the activity. This could be an example for compensating control. I cannot apply the original control, which is the data encryption, but I can use third-party software to do this task for me. Another example is the shared account. It is not recommended and it is forbidden by many security standards, such as payment card industry standard, as well as many of the security standards, to use shared account or default account, like the accounts that we use in Linux, such as root account or administrator account in Windows. But we might encounter a case where there is a limitation for creating unique user accounts for each individual. So we might research and find another compensating control here, which will be basically we will allow people to reach this application, which has this limitation, only through this device or this remote desktop machine. And in order to get access to application, user need to log in first to the RDP session on this device. And in that case, the system will be able, or the remote desktop machine will be able to track who is the actual user who log in or who did a login in this particular time. And then we will allow this user to deal with this application using the default username from this RDB session. So we can here establish like a trace between who did the activity and who did the login during this time frame on this RDB machine. I hope this example here is clear. So compensating controls in a nutshell is the control that we can use in case of we cannot use the original control. When you got a security vulnerability and you are not able to apply the patch, you might consider to stopping the vulnerable service. This is a compensating control. You might consider to apply IPS engine or apply more restrictive access requirements. This is also a compensating control. You keep the compensating control running as long as you didn't apply the required control yet. Once you apply the required or the original control, in that case, there will be no need to maintain the compensating control. Countermeasures is another kind of control, but it is designed to address a specific problem or a single issue. To be frank with you, I have not encountered so much cases where I need to apply a countermeasure in technical field. But in physical security, we might have specific countermeasures for specific scenarios. For example, any facility should have like let's say an emergency exit door, and this emergency exit door should not be locked from inside or outside, because the goal here is to allow users to evacuate the building if something wrong happened. So we can create or we can design the security door in a way that makes sure only the door is accessible from inside. So we develop a special lock, and this lock can be released from inside only, and no one from outside can open. This could be a countermeasure. But what if someone, or let's say it's not a countermeasure, it is a design. By design, this is how emergency doors that you usually deal with looks like. But what could be our protection or prevention if someone misused this door, like opened this door from inside and allowed someone unauthorized to access? In that case, we might need to develop a certain control that target the detection of this particular problem, which could be, for example, an alarming system, and this alarming system will be triggered once this door is opened. If this alarm has been triggered during an incident, it's okay. But during a normal operation, if there is no fire alarm and this alarm has been triggered, that indicating the door has been opened, in that case, we have a problem. We have someone who is misusing or abusing this emergency exit door. I hope that's clear for you.